Hello Math 2, this is Mrs. Bricky and this video is for Unit 6, Lesson 1. We're going to be talking about arc measure. So just a recap of your prior knowledge of some vocabulary terms. This whole unit will be studying circles, and a circle is a set of all points in a plane that are equidistant from a given point that's called the center of the circle. So we've got this diagram. Our center right there is in purple, and a circle is just all of the points that are the same distance away from that center. And once you fill in, if you found every single point, it would create this circle. You'll sometimes see notation like this. That means circle P. If the center was point P, this would be circle P. So if you see that notation, it just is telling you the circle that has the center at point P. Any segment that is between the center and the edge of the circle is a radius of the circle. And any segment that goes from one side of the circle to the other through the center is called a diameter. Some new words for this year that might be new to you. I've got a picture here on the left that shows a bunch of chords, and a picture on the right shows some segments that are not chords. So what makes a segment a chord? Something you might notice is that both ends of the chord are on the circle's edge. Another example of not a chord would be something that is connected maybe on one side but does not go all the way to the other edge. So this image shows some arcs on the left, and on the right we have things that are not arcs. So you can see that an arc is a portion of the circle that is between two endpoints that are on the circle's edge. So it's just a little part of the circle. It has to be on a circle to be called an arc. So this one is not an arc because it is not on a circle. And this is not an arc because it's a chord. And finally, we're going to be talking a lot about central angles. So these ones on the right are central angles, and the ones, I don't know my left from right. The ones on the left are central angles over here, and the ones on the right are not central angles. So what hopefully you are observing here is that a central angle is an angle with the vertex of that angle at the center of the circle. So you've got that vocabulary in your notes written out for you with those definitions, and in this diagram it shows you an example of each. We've got a chord, a central angle, and an arc. So when we talk about arcs, they can be classified according to their size. And when we write the notation of arcs, we use this little sort of arch above them, this little curve. So when we talk about segments like chords, you may have seen those before. It has a straight line above. This would be like a chord in a circle from A to B. An arc in a circle will put a little arc on. So when we talk about arcs, a semicircle is an arc that is half the circle. So the endpoints of a semicircle are the endpoints of a diameter. So in this case, on this circle, we would have this semicircle right here. Or we could also say that we have a semicircle, on the other side down here. This is also a semicircle. So a semicircle is an arc. A minor arc is any arc that is less than half of the circle, so less than a semicircle. So we've got minor arc AB here. A major arc is an arc that is more than half of the circle. When you name a major arc or when you see a major arc listed in a problem, it will always have 3 points listed. So this blue major arc on my circle goes from A to D to B, so almost all the way around the circle. It has those 3 letters to designate it. So anytime you're designating a major arc, you have to use 3 points. If you just say AB, you're talking about this guy. If there's only 2 letters in the arc's name, we assume you're talking about the minor arc. A minor arc could have 3 letters. So if we had point E here, we could call this a EB. So 3 letters does not guarantee that it's a major arc. Just if you have a major arc, you have to use 3 letters. For a semicircle, you can use 3 letters. So DAB is a semicircle, or you can just use 2. When you just use 2, it's not really specifying which side of the circle you're talking about, but both the upper side in this case and the lower side are semicircles. So with a semicircle, you can use 2 letters if you want. All right, so in your homework assignment, there is some vocabulary practice. Please note, if you're doing this, that there is more than one possible answer for most of these. So when it says to list a chord, there's definitely more than one chord in that diagram, so you just pick one to write down. Try to use good notation. Anything that's a straight segment, you're going to put a bar above the letters, like QR is a segment. Anything that's an arc, you're going to put the arc above. So practice that up. Okay, so today our main focus is to talk about arc measure. So anytime we're going to be talking a lot about central angles. Central angles can range from very small, 0 degrees, 1 degree, 2 degrees. And the largest central angle that we could have would be 360, because 360 is all the way around the circle. And the central angle could be anything in between there. Well, when we start talking about arc measures, we know that the arc is the edge of this circle. Arc measure is also measured in degrees, and the measure of an arc is equal to the measure of its central angle. So if I have a 76-degree central angle, I also have this arc that measures 76 degrees. So arc measure doesn't tell us how long it is. The circle could be different sizes. We could, zoom out, and now that arc is longer, but it's still a 76-degree arc. So arc measure is in degrees. So an entire circle would be 360-degree arc. A semicircle would be a 180-degree arc. And just whatever that central angle is, if it's 60 degrees like in this diagram, the measure of arc AB would also be 60 degrees. So as we work with these circle diagrams, we're going to make use of diameters a lot when we have them. And we'll make use of this idea that the entire circle is 360 degrees. All right, so here's our first diagram. In this diagram, one of the things we're going to be focusing on is the diameter that we have there. Diameters divide circles into two 180 degrees arcs, and we can use diameters to help us as we're solving problems with circles. So we've got a list of arcs over here to find. Oftentimes with a circle, the best thing to do is to sort of write a few things down on your diagram and then go answer the questions. So we've got this diameter from D to B. So that means this will be a 180-degree arc. We have a 75-degree central angle right here. Well, that means we have a 75-degree arc from A to B. And then this upper side of the circle also adds up to 180 degrees. So we can calculate this one by subtracting 75 from 180. So that means this arc is 105 degrees. So now that I've labeled all my arcs, I'm going to read through these questions and answer them. The measure of arc AB that's right here, 75 degrees. So that's a minor arc. The measure of arc AD from here to here is 105 degrees. And that's also a minor arc. So remember, minor is anything less than 180, kind of like how you're a minor when you're less than 18. Our next arc is BD. Well, BD, we could think of it as this bottom half of the circle if we want. So that's 180 degrees. That's a semicircle. And then our last arc is ADB. So from A to D to B. So we have to do the arc between A and B that has D in it. So this is definitely a major arc. Now there's two ways that we could calculate that major arc. So one way is to add together 105 and 180. The other way is to think about that the whole circle is 360 and we're just leaving off that 75-degree piece. So both of those ways are valid ways for calculating the measure of arc ADB. Just whichever one that occurs to you. Sometimes if you're stuck though, we forget that we can use subtraction. So keep that subtraction idea in the back of your head for if you're stuck on a problem ever. All right, so this was 285 degrees. Whether we add it or subtract, we get 285. Okay, sometimes there's markings on the diagram that are going to let you know that two arcs are congruent. So in this case, you can see we've got this marking here and this marking here. Those two arcs are congruent to each other. Also, recall that when we have two lines crossing, the angles created are called vertical angles and they are equal to each other. So in this diagram, we also have these vertical angles, and that means that arc EF is going to be congruent to arc CB. So let's see what we can figure out about this diagram. It says the measure of angle BF is equal to 126 degrees. And our goal is to figure out the measure of DF. So let's first think about that 126-degree angle. If this angle, this central angle is 126 degrees, well, these two lines just crossed. So that means this angle is 126 degrees. Its arc is broken into two equal arcs. So we can do 126 divided by 2. Whoops, that's not 53. Silly brain. 63. So that divides it into two arcs that are each 63 degrees. So we have part of DF found. We found that from D to E. Now we need to figure out from E to F. Well, again, always look for diameters that can help you. BE is a diameter that cuts that circle right in half. So we can calculate EF by taking 180 degrees and subtracting 126 degrees. Sometimes I'm so bad at subtraction. Let's see, 54 degrees. All right, so now we can answer the final question. The measure of arc DF is 63 plus 54, which is 117 degrees. Okay, sometimes you're going to have to do a little bit of algebra to solve for a variable. So on this diagram, we do have a central angle with 140 degrees, and it asks us to solve for x, and it tells us that this arc right here has a measure of 6x minus 8. So our goal is to solve for x. Well, we've got a diameter right here. So if this is 140 degrees central angle, we know that this one would have to be 40 degrees because those two have to add up to 180. So the central angle and the arc have the same measure. So we can use the equation 6x minus 8 is equal to 40 to solve for x. And we'll just move some terms around, adding 8 first, and now dividing by 6 to get x is equal to 8. Sometimes you'll have markings on a diagram that let you know two of the angles are congruent. So let's do example A here first. It asks us to find the measure of arc XW. Now, sometimes you can't at first figure out what that arc is. Sometimes you have to do a little bit of work to get there. So it looks like we have 3 arcs that are known. And this is an 85-degree arc since it's an 85-degree central angle. And then we have 2 angles that are congruent. So we don't have any diameters here to help us. So we're going to have to start with the idea that the whole circle is 360 degrees. And we're going to subtract the arcs that are known. So 360 minus 91 minus 85 and minus 64, and that gives us a total of 120 left. But there are 2 arcs right now that we haven't accounted for, this one and this one, but they're equal to each other. So we can take that 120 and divide it by 2. And so each of those must be a 60-degree arc. So we have our answer now. The measure of arc XW, 60 degrees. Sometimes you won't be asked for the measure of an arc. You'll be asked for the measure of a central angle. So this problem says find the measure of angle LON. So LON is this. We're looking for this angle. That's the answer we're looking for. In this diagram, you can see that we have x's. So we're going to have to solve for x at some point. So we'll solve for x, and then once we know what x is, we'll do a substitution back to figure out our answer. So these 2 markings, they do tell us that those 2 angles are equal to each other. Sometimes you'll see them offset a little bit. Like you can see this one is a little bit smaller, like closer to the center than this one. The reason that they offset those is that if we didn't have them offset, it would just look like one marking, and it maybe wouldn't be clear if that marking was talking about this full angle. So what they'll do instead is just offset them a little bit to show that those 2 angles are equal. So we've got 2 equal angles. Well, if this one has an arc of 5x plus 19, then this one also has an arc of 5x minus 19. So this circle is right now broken up into 3 arcs, and we have an expression for each of the 3 arcs. So now we're just going to add those expressions together and set it equal to 360 degrees. So we have 5x plus 19 plus 5x plus 19 plus 9x minus 1, and that's the whole circle. So that's 360. So on the left, if we combine up some terms, we have a 5x, and a 9x. So that's a total of 19x. And we have 19, 19, and negative 1. So that's a total of 37. So we can finish this, we can finish part of the problem solving for x here by subtracting and dividing to figure out that x is equal to 17. So it didn't ask us to find x directly, though. What it asked us for was the measure of angle LON. So we know that LON is 5x. We know that angle LON is 5x plus 19. So that's 5 times 17 plus 19. So 5 times 17 plus 19 gives us 104 degrees. So that's our answer, 104 degrees. All right, that's the last example. So try the problems in your pink assignment, or if your teacher gives you a different assignment, that's great too. There are a couple, if you're doing the paper assignment, there are a couple that are pretty challenging. Just keep thinking about which things do you know are the same, or which things do you know have to add up to 180 or 360, and really stick with those problems that are a little trickier. Thanks a lot.